All right, class, let me try another video solution. Here's one going back to chapter 3. You guys are probably working on getting ready for the test. It's number 43. It's that goalkeeper one. It says, can a goalkeeper at her or his goal kick a soccer ball into the opponent's goal without the ball touching the ground? The distance, which is about 95 meters, and the goalkeeper can kick the ball at a speed of about 30 meters per second. All right, so if I kind of made a soccer field or a pitch here, and we kick the ball up, and we're trying to get it as far as we can. This is that 95 meters, so we're trying to get it into that goal. The first and unspoken part of this is the 45 degrees. They don't say anything in the problem, but as we analyzed our projectile motion, and you can kind of see it back a few pages in chapter 3, they say an object will go the furthest at 45 degrees. So if the goal is to get it as far as you can, then 45 is the way to go. And so that is probably a big piece of this problem, because nowhere in this problem does it say kick it at 45 degrees. But it does imply in this problem that you're really trying to kick it a long distance. And so it's questionable if you can make it. And so the best you can do is 45. If you did greater than 45, you would just kind of lob up and go here. You did less than 45, it would land and, of course, bounce. And in reality, that's probably the best way to kick it into this goal, depending on where the goalie is. Obviously, you want to go over all the opponent's head, but you probably want to bounce it in anyways. It's not easy to get a ball directly into the goal, as long as you got it over the head and a couple bounces. And anyways, but we're not shooting for something with bounces in, and we're not shooting for something more than 45. So I'll say it again. Unspoken in this problem is that the angle to kick it is 45. And that's a big piece. All right, so then, like all the other projectile ones I've been talking about here, divided into two pieces. Put your grid somewhere, and so I'll put the grid right where the soccer ball is kicked. Now, not really said here is I'm going to say that the soccer ball, where it gets kicked from, is the origin. Now, that's probably a little bit off the ground, but maybe that's matched equally by it entering the goal. So as it enters the goal, in other words, when it comes back down, we don't really want it at 0, we want it near 0, and that's where it starts. So what I'm going to do is say the position that they kick it, which is a little bit off the ground, is 0, but the position that it lands, quote, land at or enters the goal is also about that same height off the ground, maybe just a little about, you're going to hold it just about waist level and drop it. And so the goal, well, is this a goal kick or a punt? No, they don't say. So it just says a goal keeper. And so if it's a goal kick, you would be out on the penalty box line, and that's 6 yards out. Opponent. And then it would really be on the ground, where if the goalie had grabbed it with his or her hands, then they can run forward, actually all the way out to the penalty box, about 18 yards, and then kick it. Anyway, I guess I'm getting into too much detail that they don't really care about here. So we're going to take their number as 95, and since they don't really give us too much, I'm going to make this kind of assumption in it. But I think the big one they wanted to test us on here was the 45 degrees. Now, coming over here in the x direction, same idea. I'm going to say where it starts with is 0, and then where it's going to land is 95 meters down. Okay. And most soccer fields are about 120 yards, so yeah, I guess that's about right. Anyway, I'm babbling on here. I should just talk about the numbers that they give us here. So then, of course, an unspoken piece of all of these projectile motions is that they've given us the acceleration, both x and y. And then, of course, the initial velocity in the x direction is the initial speed cosine of the 45 degrees. And you saw me work that out a lot, so let me leave that there. And the other one would be the velocity in the y direction, v naught sine of 45. And maybe I'll just get a number then for each of these. And fortunately, they would be the same number since the sine and cosine of 45 are the same. So this would be 30 times the cosine of 45. That's that 0.707, coming up to be 2121. And just to show you, 30 times the sine of 45 is also 2121. All right. So again, does it make it, without bouncing? So if I were to write out the equation of the position in the x, noting, as we already said, the acceleration in the x is 0. I'll cross that one out. The initial position is 0. And so x equals the 2121 times t. So if it is in the air long enough time, we can multiply it and get 95 meters. But if it's not in the air long enough, it won't go 95. Or if it's in the air for a long time, it might go more than 95. So if it goes more than 95, I think we can answer it by, yeah, the goalie player could do it. Now, 95 would put it too far, so maybe they'd kick at a smaller angle or not as a great a speed. And so, but again, the reason we're picking the maximum speed of 30 and the maximum angle, the 45, or the angle that makes it go its maximum range, is because we're trying to see, can this goalie player actually do it? Would this speed of 30 do it? And our best chances is at 45. So if we at least go 95 or greater, we're going to say yes. Now, I'm going to then use the y motion here. To then solve for time and put it over here. So as we said earlier, the final position is 0 and starts with 0. Now these starting 0, again, it's probably a little bit off the ground if it's a goalie punt. And so this one, 2 here. Okay, now the initial speed is the 2121 times t, and the acceleration being a negative 9.8, and then getting the half of it gives me a negative 4.9. So simplifying this equation gives me two factors. Two factors multiplied together to give you 0 means either the first factor is 0 or the second factor is 0. Now, the first one, maybe I'll make a comment, time equals to 0. Of course, that's a solution because it is at position 0 at time equals to 0. That's when it's being kicked. So it doesn't surprise me that time equals to 0 is a solution for when it's at 0. It's just not the one I'm interested in. I'm interested in the one greater than 0 is when it lands near or as far as we can get it towards that goal. So this is the one I want. So 2121 equals a positive 4.9 t, and then the t is the 2121 divided by 4.9, giving me 4.33 seconds. So huge amount of time, obviously. It's going a huge distance that it flies through the air. Of course, that's without any air resistance. So it's not going to go as far as we think it's going to go. But using that time over to here, so I've got the time in the calculator and I multiply it by 21.21, looks like it goes 91.8 meters. So not quite, even at the best of angles, 45 degrees, it doesn't quite do 95. And with air resistance, even less. So we're not going to make it there without bouncing it in here at 30. Now, if we can kick more than a speed greater than 30, we might make it. But there's no other angle that's going to make it go further than that with a speed of 30. So just won't make it. All right, hope that one helped.